Right, so this is a sort of, complicated question. It's the last paper in the exam, so they always are. So what have we got? So we've got a circle with a center at the origin. So the first thing we know, we have to think that basically the equation of a circle is x squared plus y squared equals r squared. Okay, remember that the r is simply the radius. Okay, now a tangent to C, remember C being our circle, passes through these 2 points. Now we have to work out the equation of C. So we have to basically work out an equation for C in that form. We're going to show all of our working. Right, so let's do this. There's our x-axis. There's our y-axis. And we have a circle, and the origin is at 0, 0, the origin. Now let's a circle, so that's origin. There's our circle at the origin, 0, 0. And then we have to draw a tangent. Tangent, remember, only touches our circle at one single point there. Okay, so that's the idea of a tangent. Right, and it tells us that this tangent, so let's label this correctly. So let's say that basically here's our circle, that's what C is, and this is our tangent. Okay, so now we're told that our tangent passes through minus 30, 0, so y is 0, so this must be minus 30, 0, and it passes through 0, 10. That means y and x is 0, so that is 0, 10. Now we're going to work out an equation for this. So first of all, let's look at the tangent. So it goes from here to here. So can we work out the gradient? So gradient, we know, is rise over run. So from here to here, it rises by 10. And the run is from here to here. So that is 30. That's our rise over run, which means the gradient is 1/3 when we simplify that fraction. Okay, so now we've got that. Now, one of the things from the circle theorem is that we know that a tangent is perpendicular to the radius. So we're going to use that fact. We're going to draw a line from our tangent to the center. That is going to be at 90 degrees. So now we know that that's perpendicular, and if 2 lines are perpendicular, the gradient of the first line times the gradient of the second line is equal to -1. Okay, so the gradient of the second line is the negative reciprocal. Okay, so our first line, we worked out the gradient was 1/3. We went to -1. So the negative reciprocal is -3. So this is the gradient of our second line. Okay, and that's our radius that goes to the center of the circle. So now we've got that part. Right, now we know that the center is at the origin. So the x is just going to be x and the y is going to be y. It hasn't been transformed or moved from the center, from the origin. All we have to do is work out what r is. Well, this tangent only touches the circle at one point, which is on the circumference. So if we can find that point, we can find out how far it is from the center and work out the radius of the circle. Let's do that. So I want to find that point. How do I find that point? Well, remember, it's an intersection of two lines. So it means that point is on the tangent and it's on the radius. So we need the equation of the tangent. The tangent is equal to y equals 1/3 x plus 10. You need to remember here, this here is our y-intercept. Okay, and we can see our y-intercept there, where it's 0x 10. So now all we have to do for the intersection is we say that the tangent is equal to the radius, because that point is on both lines, so it satisfies both equations. So 1/3 x plus 10 equals minus 3x. Okay, right, so we have to resolve for x. So let's times both sides by 3. So 1/3 x times 3, that's x. 10 times 3, that's 30. Minus 3 times x times 3, that's going to be minus 9x. Okay, let's take away the 30 and add 9x. So I've got x plus 9x, that means I've got 10x over here. Take away 30 and take away 30, so that's going to be minus 30, which means that 1x is equal to minus 3. Okay, so that point is x is minus 3. What's the y that goes with it? Well, if I put it into either of my line equations, it's going to minus 3 because that's simple. So minus 3 times minus 3, y is equal to 9. Okay, so now I know what this point is. This is minus 3, 9. So that's what we've done. We found our point of intersection, and this is our point of intersection right there. Okay, we're almost there. Now we just work out the radius. So the distance from our point of intersection, which is on the circumference, to the center is our distance. Now, I can turn this into a triangle. So the last thing we need to do, I've got my triangle. I know that this is 0, 0. We worked out that this is minus 3, 9. And so we know that this point here is minus 3, 0. Because the x is the same, and here the y is the same. And that's a right angle triangle. So that means that this side must be the part that goes from the circumference to the center. That is our radius. How do we find that length of the triangle? Well, okay, this side is 9 because it goes from y is 9 to y is 0. And this side goes from minus 3 to 0, so this side is 3. So we have to use our old friend Pythagoras. So we've got 9 squared plus 3 squared is 81 plus 9 equals 90. Okay, so 90 is equal to the radius squared. Well, that's what we want. Remember, the equation of the circle is x squared plus y squared equals radius squared. So our final answer, the equation of the circle is x squared plus y squared equals 90. Okay, so remember, this is r squared from our Pythagoras, x squared plus y squared because the centre is at the origin. Hope that makes sense.